You are welcome to today's episode of Free JAMB Marks series for JAMB UTMA 2026. Without wasting much of our time, let's quickly obey the protocol of the lecture, which is enabling full screen in your device by tapping on the icon located around this place that I'm hovering my mouse. And remember that as you take this lecture, ensure to make notes in order for you to get the mark that is attached to this question, because we are distributing mark. What I'm doing right now is distributing free marks in JAMB UTMA 2026. So take advantage of this. Make your notes as you take the lecture. Let's go to the question immediately. JAMB repeated question. The question reads, which of the following methods is used to remove temporary hardness of water? Which of the following methods is used to remove temporary hardness of water? A. Boiling. B. Addition of washing soda. C. Ion exchange method. D. Lime soda process. What's the answer? Let's find out. Before we find out the answer to this question, we have to get an understanding of what hardness of water is. Okay? Hardness of water. Hard water has the following properties. 1. Does not readily form lather with soap. That is always difficult to form lather with soap. Do you know what is lather? Lather is that foamy impression, okay, formed when you dissolve soap in water. That foam, we usually call foam in Nigeria. So that's lather, okay. So hard water hardly or barely forms lather with soap. Then number 2, forms fuming on the inside of utensils, pipes, and so on and so forth. Especially kettles and pots. When you use it to boil them, they form fury around the inside of the cooking utensil. Okay. Then the third one is high boiling point. You notice that the water takes longer than 100 degrees centigrade to get to boiling point. So these are the properties of hard water, and so on and so forth. Moving on. Causes. So what are the causes of hardness of water? The first cause here is high concentration of dissolved calcium ion, calcium 2 ion, and magnesium ion. So these two ions are responsible for the hardness of water. Calcium ion and magnesium ion, both of them calcium 2 ion and magnesium 2 ion. So both of them are responsible for hardness of water in general. Hard water has high concentration of these ions, calcium and magnesium. That's why they are hard. That's why they are called hard water. Okay. So how does it happen? How does hardness of water occur? When water gets in contact with soluble salt like limestone, chalk, or gypsum. You know what gypsum is? The ore of calcium. Okay. Where it occurs naturally as gypsum. A combination of various elements including calcium forming gypsum. Moving on. Types of hardness. What are the types of hardness of water? The first we have here is temporary hardness, caused by bicarbonates, such as the calcium hydrogen triazocarbonate and magnesium hydrogen triazocarbonate. So both of them are the causes of temporary hardness of water. Okay, so remember, the ions are constant in the causation of hardness of water, which is calcium 2 ion and magnesium 2 ion, irrespective of the type of the hardness of water. Okay, so the ion is constant, but it depends on the form of the ion. So the form of the ion, calcium and magnesium 2 ion, that causes temporary hardness of water is the calcium hydrogen carbonate and magnesium hydrogen carbonate. Okay, so how do we remove temporary hardness of water? Remove by boiling. So when you boil the temporary hard water, bicarbonate in it, this calcium hydrogen bicarbonate or magnesium hydrogen carbonate, decomposes in the presence of heat to give carbonate such as calcium triazocarbonate 5. And during the process, carbon 4 oxide is released as a byproduct for that. So carbon 4 oxide is released to the atmosphere and an insoluble carbonate is formed as a precipitate, okay, which can be filtered out of the water and the water becomes soft. Moving on. The second type of hardness of water is the permanent hardness of water, and it is caused by chlorides and sulfates of the same calcium 2 ion and magnesium 2 ion. Like I said before, both of these ions are constants. They are the root cause of hardness of water. So they are constant, whether permanent or temporary, they are constant. What matters is the constituent elements, the form, okay, the form of the salt, the form of the salt at that particular time. That's what matters, the type of hardness of water that is present. Okay, so for permanent hardness of water, calcium chloride and magnesium tetrazosulfate Cs are the cause. Okay, calcium 2 chloride and the magnesium tetrazosulfate Cs are the cause of permanent hardness of water. And permanent hardness of water cannot be removed by boiling. Take note of that. It cannot be removed by boiling. Moving on. Effects of hard water. The first effect here is poor lathering with soap. It's difficult for the soap to form that foam, okay, to lather. Very difficult. The second is scale formation in kettles or foreign boilers and what? Pipe. Foreign boilers and pipe. Formation of scale and kettle. So you know when the scale form on the inside of the kettles when you cook. So those are the effects of hard water, okay? The next we have here is reduced efficiency in detergent and heating system. So it's usually difficult for detergents and soaps to work to the maximum when you are using hard water. And when you are trying to boil hard water, it usually takes longer to boil, okay? For it to get to a boiling point, it usually takes longer. And the final one we have here is aesthetic issue in laundry and bathing. When you say aesthetic issue, you are talking about beauty. In laundry, when you are using it to wash clothes, it destroys your fabric. Okay, it destroys your fabric. And when you are using it to bathe, those salts can be harmful to your skin. Okay, they can be harmful to the skin and cause skin irritation. Methods for removing hardness of water. What are the methods for removing hardness of water? How do we remove hardness of water or make water soft? Okay, removal of hardness of water is also called or also known as softening of water. So how do we soften water? Number one is boiling for temporary hardness only. That's where boiling work, only for temporary hard water. So what happens when you boil? When you boil a temporary hard water, it decomposes bicarbonates into what? Insoluble carbonates. Okay, this bicarbonate is soluble. That's why it's able to make the water hard. But when you heat it up and it decomposes, it gives an insoluble precipitate, which is carbonate, such as calcium triisobicarbonate for limestone. Okay, carbon dioxide is evolved or liberated as a byproduct. Okay, and the next one we have here under boiling is carbonates precipitate out as calcium triisobicarbonate, and also magnesium hydroxide. When magnesium hydrogen bicarbonate is responsible for the temporary hardness of water. So when you heat it up, magnesium hydroxide is formed as an insoluble precipitate, which can be filtered off from the water. Number two, the second method of removing hardness of water is addition of washing soda, which is sodium triisobicarbonate 4. How does it remove hardness of water? It reacts with calcium 2 ion and magnesium 2 ions to form insoluble carbonates. It reacts with calcium 2 ion and magnesium 2 ion to form insoluble carbonates. It removes both temporary and permanent hardness of water. So it removes both temporary and permanent hardness of water. That is the property of this washing soda. So it can be used to remove both. Note something very important. Permanent hardness of water is mostly removed through industrial methods. They include ion exchange method, synthetic resin process, lime soda process. So these three methods are used to remove permanent hardness of water industrially. When it is commercially required to remove permanent hardness of water, these three methods, ion exchange method, synthetic resin process, lime soda process, are used on a large scale. Moving on, the third method of removing hardness of water is the ion exchange method. Remember, this method is used to remove permanent hardness of water. It's used to remove permanent hardness of water. And this ion exchange method, we use compounds like zolytes and permutites. So in this ion exchange method, we use zolyte and permutite processes. Hard water passes through sodium zolyte. This is the chemical formula of sodium zolyte. And when you pass hard water through sodium zolyte, calcium 2 ion and magnesium 2 ion are exchanged with sodium ion. So after the exchange, soft water is formed. Okay, so the water becomes soft because the ion has been exchanged. Okay, the ion is no longer present. It has been exchanged with sodium ion. So zeolite is regenerated using brine, which is molten sodium chloride. Take note of this last statement. Zeolite is regenerated using brine. Brine is what? Molten sodium chloride. Okay, molten sodium chloride. That's brine. The fourth process of industrially or commercially removing permanent hardness of water is through synthetic resin process. Cation exchange resin process, whereby calcium 2 ion / magnesium 2 ions are replaced with hydrogen ion. Okay, so this process is used to remove hardness of water through the exchange of the cation. Okay, exchange of cations. So the next, after exchanging the cation, anions are also exchanged. Okay, anion exchange resins remove accompanying anions, such as the anions like chloride and tetrazosulfate 6 ions. Okay, both of them are anions, which are what? Negatively charged ions. Okay, remember, cations are positively charged ions. Okay, so the final one we have here is what happens next? Produces deionized water. So if you see a question in your JAMB UTME 2026, you have been asked that during the synthetic resin process, what kind of water is formed? The answer is what? Deionized water. So deionized water is formed during the synthetic resin process of softening of hard water. The fifth and the final process of removing hardness of water industrially or commercially is adding of what? Lime, which is calcium hydroxide, and soda ash, which is sodium triisobicarbonate. Okay, so when you add both of them to hard water, it forms insoluble calcium triisobicarbonate 5 and magnesium hydroxide. So both of them are insoluble. Both calcium triisobicarbonate 5 and magnesium hydroxide are insoluble. So what do you do immediately? You just filter them off from the water, so you get a soft water. Used in large-scale municipal or industrial softening. So this lime soda process is used in large-scale municipal. You know what a municipal process is? A municipal scale is for majorly for the cities. Okay, supplying of big cities. Now let's go back to the JAMB repeated question. The question reads: which of the following methods is used to remove temporary hardness of water? A. Boiling. B. Addition of washing soda. C. Ion exchange method. D. Lime soda process. What's your answer? You answered correctly. The correct option is not lime soda process. The correct option is not C, ion exchange method. The correct option is not B, addition of washing soda. The correct option is boiling. Temporary hardness of water is boiling. Congratulations, you just earned your free mark in JAMB UTME. A quick summary of this lecture reads, hard water contains the ions, which are calcium ion and magnesium ion. So both of these ions are responsible for hardness of water. Remember, it's magnesium 2 ion and calcium 2 ion. Okay, so in case you see different ionic level of both of these elements among the options in your exam, so pick calcium 2 ion and magnesium 2 ion. They are magnesium 2 ion and calcium 2 ions. They cause what? Scaling and reduce soap efficiency. So it's difficult to use soap in a hard water. Very difficult to use soap in a hard water. So temporary hardness is removed by boiling. That is the basic method of removing temporary hardness of water. A cost-effective method and an economical method of removing temporary hardness of water. While permanent hardness of water requires chemical, of which those methods includes the lime soda method and the synthetic resin process. Industrial systems often use lime soda or the resin processes. Okay. Thank you so much for taking this lecture, and I hope you picked one or two things in this lecture that is going to be beneficial to you in your JAMB UTME 2026. Congratulations, as you just earned 1 mark in chemistry, JAMB UTME 2026. Do well to subscribe and follow for more at Nkwado Augustine across all social media platforms. Hope you made notes during this lecture. After this lecture, revise that note immediately so that this free mark sticks to your brain. When you see it in your JAMB UTME exam hall, you are going to do nothing but earn the mark. Do you have any questions on knowledge gap, or you have any topic suggestion you want us to treat? Drop them in the comment section and I will do justice to your knowledge gap and questions as soon as I come across them. At this point, I'm out.